Meaning of a rational exponent. Well, rational means fraction. So we're really asking ourselves is what is the meaning of exponents with fractions? So let's start with the definition in the book. The book has that something raised to a fraction turns out to be a radical. Kind of weird. The denominator of your fraction turns out to be what they call the index. So we have that the index is the denominator, and you notice that's true on both of these. The numerator turns out it can be raised to that power on the inside of the radical or the outside. That makes sense. If you have x cubed, it is x cubed, but the denominator is going to be the radical. That's what's different. And the reason they have two different definitions here is because it does turn out that the raising to that power can be on the inside of the radical, like I said, or the outside. To see this, let's do some simple examples first. Let's look at 16 raised to the 1/2. What does that mean? You can take 16 raised to the 0.5 in your calculator, and you'll notice you'll get 4. Or if you want to see it without a calculator, we know 16 is the same as 4 squared. So we change that to 4 squared. And we still have to the 1/2 power, so I'm just changing the 16 to the 4 squared. And we know from our first chapter, the laws of exponents, we multiply these two exponents together, and 2 times 1/2 turns out to be 1. So you can see that 16 to the 1/2 is 4. Because 4 to the 1 is just 4. So again, I'm just using the law of exponents from chapter 1. A to the n raised to the m, we know that we multiply those two exponents. So what is, by the way, 6 to the 1/2 can be written, if you look at their definition, as the square root of 16. Because isn't the square root of 16 4? By the way, the reason it can be written as 4 is because the index, I know, should be 2 here, the exponent 1. But whenever we have an index 2, we do not write it. So the square root of 16 is what it turns out to be. And we can see that it's 4. So something to the 1/2 power just turns out to be the square root. Let's look at another example. Let's look at cube root. 8 to the 1/3. So again, let's do it without exponents first. So that would be 2 cubed is what 8 is, raised to the 1/3 power. What we do is, using that law again, we multiply those. 3 times 1/3, which is 1. See a pattern here, right? Because we're getting rid of that cubed by multiplying by 1/3, dividing by 3. And by the way, 8 to the 1/3 is the same thing as cube root of 8. So if you did 8 to the 1/3, looking at the first part of our rule, that turns out to be the index. And we know the cube root is 8 because 2 times 2 times 2 is 8. So that's with a numerator of 1. Let's try a numerator without 1. What if I had 8 to the 2/3? Well, let's first do it without, again, any radicals. So again, 8 is 2 cubed, and we still have a 2/3. Still, we're going to multiply those using our law of exponents, and that would be, the 3's would cancel, giving us 2 squared, which is 4. Let's see if that's really the same as that first example, cube root of 8 squared. Well, we have to do the inside first. So the 8 squared is 64. Cube root of 64 is indeed 4, because 4 times 4 times 4, 16 times 4 is indeed 64. So you see that that does work. Okay, let's look at the third one. Since we have a numerator in this case, it could be the second or the third. So we have cube root of 8, but can we put the squared on the outside? Well, let's try the cube root of 8 first. We know the cube root of 8 is 2, and then we have 2 squared, which is indeed 4 again. So you can see that it does make sense. If I did this with variables, scroll down just a little bit, if I had an x to the 1/3, what would that be? What would that mean in terms of radicals? The denominator becomes the index, cube root of x. If I had the example x to the 2/5, what would that be? Again, the index would be the denominator, and again, it doesn't matter if you put the square on the inside or the outside. Even if I changed this and made this, I don't know, 5/3, the numerator larger than the denominator, then it's still the same. The denominator is the index, and the exponent, as always, is the numerator. So that's what a fractional exponent means.